In this video, I want to talk about margin of error. The idea behind margin of error is it's a way to determine whether results from a test really should be taken seriously or results from an experiment should really be taken seriously or not. Meaning, for example, if I were to take a quarter and flip it and it comes up heads. Well, I could say, okay, I just ran a probability experiment, and since it came up heads, I flipped it one time, and it came up heads one time. I would now say that anytime I flip a quarter, I'm going to get heads 100% of the time. Now, obviously, we all know that's not true, right? There's heads or tails, and there's a 50-50 shot. There's a 50% probability of me getting either side. But even if I flip it a second time, it could come up heads again, right? There is a reasonable shot. It could come up heads twice. And if it did that, then I might say, okay, well, now I've done it two times, and heads has shown up twice, so clearly I'm correct in saying that heads is going to show up 100% of the time. Heck, I could even flip it a third time, and even if it does come up tails, I could say, well, 2/3, 67% of the time, it comes up heads. And none of that would really be true. And of course, the reason why that's actually not true and why I'm able to get those results but have them not be true is I'm simply not running enough trials, right? I'm only flipping the coin 3 times at the most in that scenario. I certainly need to flip the coin more times if I really want to get any type of accurate result. And so the idea for margin of error is it is a mathematical formula that allows us to determine whenever someone wants to make a statement about why their results are different than results gotten from a like study, but one that did different amounts of trials. Margin of error is a way to determine whether it's fair to actually recognize the difference in those statistics, in those results, or whether the difference is simply based off that number of trials that you've done. As you can see, the formula for margin of error is 2 times the standard deviation divided by the square root of the sample size. To be clear, we are referring to the standard deviation of the original study, the one that you are comparing your results against. So let's look at an example here, because I recognize that that explanation may not make the most sense, because I'm just talking. If we look at this example, it says, a college recently reported that the mean score on the SAT mathematics exam is 508, with a standard deviation of 121. Washington High, meaning some random high school, believes that its seniors score higher than the national average. So, the school randomly samples scores from 200 seniors. They find a mean score of 550 for that mathematics exam on the SAT. So the question is it fair? Is Washington High correct in its belief that its students, its seniors, score better than, comparing to the nation? And so certainly looking at this, you are inclined to say yes, right? 550 is certainly a greater mean than 508. But the point is, the 508 mean is the entire nation, right? That's a ton of kids. Whereas Washington High is only sampling 200 seniors, right? They're only sampling 200 people. So the question is, the fact that their mean is higher, does that truly mean their kids are smarter? Or is it simply just they only sampled 200, and so you would expect a bit of fluctuation? You wouldn't expect only 200 kids to perfectly nail the average that you're getting from surveying all the people taking the SAT across the nation. That's the idea behind this. So, if we calculate our margin of error, like we said, our formula for margin of error would be 2 times our standard deviation, which we're told is 121, divided by the square root of our sample size, meaning how many people did they sample? Well, they sampled 200 seniors. If you take 2 times 121 divided by the square root of 200, you're going to get approximately 17.11. Really, I should probably do this. Approximately 17.11. Okay, I'll let you verify that on your calculator on your own time. The idea of that is, now we want to look at the national mean, the 508. We want to add and we want to subtract 17.11 from 508. Well, if we add 17.11, we get 525.11. If we subtract it, we get 490.89, meaning our range of acceptable scores, or however you want to say that, would be 490.89 to 525.11, meaning any score that is within that range is purely just a difference based off the smaller sample size. It is not something that any conclusions should be drawn from. However, Washington High seniors had a mean of 550. That is outside this range. And so what we can say from this then is, because 550 is so much above the mean of 508, it is outside the margin of error, which means yes, it really is fair for Washington High to say that they feel like their seniors do better on average than the rest of the nation, because they are so much greater. If it had simply been, say, 520 as their mean, 520 would not be acceptable, because that would be within the margin of error. So really they'd have to say, well, we can't really prove our kids do better, it's really just a fluctuation from our smaller sample. That's the idea for margin of error.